Hello, my friends of Hatari Labs. My name is Or Montoya. We are going to do a tutorial on crop recognition, and this crop recognition will be done with a Python code that we have implemented on a new Python package that is called HatariTools. HatariTools is a new Python package that summarizes or is a miscellaneous package of all the develop that we have uh, of most of the codes that we have developed here in Hatari Labs. Okay, so with this code, we are going to select from some selected crops. We are going to identify other crops, and this will be done on a geospatial raster file. Okay, so let's close everything now and let's start again. So we are going to use Anaconda prompt. Okay, Anaconda prompt. On the description of the video, you are going to receive the zipped file that you have to place under documents, cd documents, cd crop. Okay, here is you are going to receive the zipped version of this file, and here you are going to launch Jupyter Lab. Okay. Okay, great. Okay, first we need to if you have Hatari tools for any case, but you have to upgrade the Hatari tools just in case that there is, okay, pip install score capital U Hatari tools, because just in any case there is some fixes, you are going to work with the latest one. Okay, great. So now we have it, and then we are going to start a new notebook. Okay, great. So in this new notebook, yeah, this will be P0. HatariTools also implements some functionality to make it faster. Uh, to This functionality makes it faster for the development of these workflows. Okay, so there are some templates, uh, and you can also download the templates from the package as well. So from HatariTools.utils.import list templates, copy template. Okay, great. So list templates. Okay, so we have two templates, but the template that we are looking for is the number 2, that is for the crop recognition. So we are going to crop recognition, copy template. Of crop recognition, and this will be agave, because we are going to work with agave. Okay, and it creates this agave file. Okay, great. So first I'm going to open QS. Okay, and let's work with this agave file. Okay, so we are going to start looking for the crop counting, and as well for matplotlib, just in case. So the crop, okay, first we initialize the crop counting engine. So the crop counting engine has been initialized. Okay, and here we are going to look for our raster file that is in ODM orthophoto, and this is called agave crop course clip. Okay, you can work with this, but however it will take more time, so just for the purpose of this will be agave course clip, and then here this will be of shape, no, of shape files, the points, shapefiles, it will be agave.7.shapefile. Okay, so we run this. Okay, so we are working with the PSG84, and the raster unit is, I mean, this is in degrees, so it's really small. Okay, these are the points of the selected. Okay, let me show you here. Home. Crop recognition, shapefile. So here, these are the points, and this is the points, and these are the crops. Okay, there are some. Okay, in this tutorial, there are some recommendations for the crop recognition, and one of the first recommendation is that the the orthophoto has to be taken at noon, okay, when there is the minimum of shadow, because the shadow is something that really prevents the this recognition. And the second is that the crops should not cross one with each other. Okay, when they crosses one with each other, actually it's really hard for them to be for also for the recognition. Okay, even that this figure has these two disadvantages, the work that it does for the recognition is quite how to say, quite interesting. Okay, so it really does a nice work. Okay, so let's work with this. Okay, so here, okay, here we see that this is in degrees. Okay, so this is, okay, we can measure in degrees, however, it's not the more intuitive. So this is 0.00001. Okay, so because we want to sample the amount of pixels, okay, that we are going to use. So let's go back here. Okay, so this will be 0.01. Okay, so the amount of pixels is 19 pixels. Okay, so based on that, okay, so this is will be the radius. No, this will be the size in pixel of the crop. Okay, but we have to give some, let's say, offset space, so this will be 35. Okay, so, and then we have these reference images. Okay, so this, look how the shadows are really spoiling the recognition. Okay, so that's why we recommend to use imagining without shadows, or drone orthophoto without shadows. Okay, and then we have an histogram. Okay, so we have an histogram to see which is the coincidence. Okay, they are really low, so we are, okay, so we are working with a maximum 0.2, while 1 is a full recognition, so it's really small, but we are going to see that. And then we are going to work with, here we can work, okay, we can do a zoom in the, because, okay, we can do a zoom just to select which will be the threshold of the similarity. So let's see that we are working with 0.25, so there are really small number of coincidences. 0.25. And Okay, so we have this for all the, there are like 10 images. Okay, and since there is a lot of coincidence, we need to cluster them. So we do that with a birch filter. And then we can plot our result. And this is the plot of the result where you have the samples and then you have the recognized crops. And then we can export that as a shapefile that we can open here. And this is our the recognition of the shapefile with some transparency. Okay, so these are the recognized crops. The coincidence is not that bad, taking into account that the shadows and taking into account not only the shadows but the crossing plants. Okay, so where the plant leaves are crossing one with each other. And this will be, as you see, the workflow is pretty straight. We are working with few packages. We are not required to to implement some engines, and then you can work with that with bigger. Okay, you can work with bigger library with bigger images. Okay, and then you can work with better images as well. I mean, uh, images without shadows and of images of crop isolated one from each other. Okay, so that is our tutorial. So all the files will be in the description of the video. Just to remember that we are a platform of knowledge sharing in water resources, and then we have plenty of courses and diplomas that you can take, and by taking these courses you are supporting our research. And the coming course at the time of this video is this groundwater modeling with ModFlow 6 and Model Muse in June and July 2025. Okay, thank you for your patience and hope to see you in coming tutorials. Have a great day. Bye bye. Bye.